Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is your MCQ and the question is in front of you. Which one is not the product of this reaction? So here you can see the substance is actually 1,3-chlorobromobenzene. So here the reagent concentrated sulfuric acid, nitric acid means it is mixed acid and it results in nitration reaction. So that's why I see four options that NO2 group substituted the proton on the aromatic ring. So this is nothing but an aromatic electrophilic substitution. And how can you remember the electrophile? Obviously student, whatever group attached here like NO2, put a positive charge on it. So you'll get the electrophile. So here aromatic electrophilic substitution takes place. The question is where the nitration will take place. The question is about the regioselectivity. So first look at the electrophile generation. Now if when you mixing concentrated sulfuric acid and concentrated nitric acid, question is who is stronger acid and who is relatively weaker acid, or you can say in this case it's acting as base. Remember, concentrated sulfuric acid is actually relatively stronger acid compared to concentrated nitric acid. So in this case it will act as acid and this concentrated nitric acid act as base. Means concentrated sulfuric acid will be dissociated as this sulfate anion plus H plus, and this nitric acid will accept the released H plus. So question, where the H plus will be taken will be at this OH. Now why? There are actually 3 oxygen atom. Now question, why the protonation will take place at this position, oxygen number 3? Because logically protonation is a reversible reaction. Any one of this position protonation can take place, but protonation on these oxygen will result a fate. Fate means these will push and it will go, and ultimately it will release a neutral molecule. Water means stable molecule. In this case water is a more stable species compared to the protonated species here. So water will produce, and in this context it will produce NO2. So NO2 in this case, this is the electrophile and the nitrogen center is electron deficient. So that's why it will participate in aromatic electrophilic substitution in the next step. Now question, where the substitution will take place? I mean regioselectivity. From the data we can understand with respect to chlorine the para position is the first major product. Second one is obviously with respect to chlorine ortho position. But why not here? Obviously very less NO2. Now question, why not here? Now if you look at this NO2 is in between the two atom. Okay, so you may consider this ortho effect, means this chlorine and this bromine bulkness will hinder the reaction at this position. But if you look at here, so you can expect the bulkness from this chlorine, but there is one proton, so that effect is absent. Even same thing is true for here. Now question, why this nitration takes place at the para position as a major product? Now in this context, remember one statement that halogen atoms are orthopara orienting and deactivating. So if I say fluorine, chlorine, bromine, iodine, any one of them if attached to benzene nucleus, it will result in ortho and para selectivity. But which case the electron density donation inside the benzene ring will be higher? Actually that will be decided by the overlap of the orbital. Okay, not only that, here two effects works. One is the plus R effect by the halogen, I mean the lone pair donation inside the benzene ring. Second, minus I effect means the sigma withdrawing, means through this carbon halogen bond this halogen will pull some electron density from the benzene nucleus, and in this case the minus I effect is dominated over plus R effect. So you may remember one thing, these benzene ring attached to halogens are orthopara orienting but deactivating. Now if you look at here the 62% product we obtain from the para with respect to chlorine. Now if you look at the electronegativity value, so electronegativity value point of view, chlorine has higher electronegativity compared to bromine. Now so minus I effect of chlorine will be higher compared to bromine, and we know minus I effect works in close proximity. For example, this ortho position have significant minus I effect compared to this para, because of the minus I effect works through sigma bond. So increasing the distance, the minus I effect is actually weakened. So here you can expect there is no minus I effect of this chlorine. Yes, Bromine's minus I effect works, but not that much strong. Point number one. Second, in this case, if you look at the second, so here the chlorine's minus I work. So question is not about the minus I effect mainly. Question is about the plus R effect. Means donation of this lone pair. Means chlorine lone pair donation inside the benzene ring is more effective. Why? Because chlorine belongs to the third row element and bromine belongs to the fourth row element, and if you want to if they want to show their plus R effect, so they need to overlap, means they form a partial double bond with this carbon, and carbon belongs to the second row element. So you may consider this carbon chlorine overlap is relatively better compared to carbon bromine, because larger size, so orbital size is more, so orbital overlap is relatively lesser. Remember, there is a condition for a bond formation: symmetry matching, energy matching. Carbon belongs to second row, bromine belongs to fourth row, so there is a lesser energy matching. Symmetry there, but lesser energy matching. That's why this chlorine carbon overlap more, plus R effect more, that will result more amount of para product. Second point, generally we observe that in aromatic electrophilic substitution, para products are the major products. Generally, there are few exceptions generally. So that's why, since the effect of Cl is more, so para position with respect to Cl is produced as the major product. So this is the thing. Now, what was our question? Our question, which is not the product of this reaction. So we understood that ortho and para. So this is number 1 as a yield, this is number 2, this is number 3. So who is in number 4? Obviously this one, means almost no product. So you can expect there will be no product formation at this position. Now if you look at this position, it is actually meta with respect to bromine, with respect to chlorine. Since these halogens are orthopara orienting, so that's why this will not be the product. So here, according to our question, who is not the product? Option A. So this is actually the right answer. So I believe it's a very easy question. You have learned a lot. And if this question appears in your exam, look at one thing: orthopara orienting, and this product is actually meta substitution. So reaction will not take place here. So this will be the product. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.